we're going to review the famous Pythagorean theorem. So Pythagorean theorem applies to right triangles, and we have the sides of right triangles that are called our two legs. Both of your legs do touch that right angle, and it's really important that you make sure you know the legs touch the right angle, and the hypotenuse is always opposite that right angle. If you misidentify the hypotenuse and think one of the legs is hypotenuse, that will totally throw off your problem. So make sure your legs are touching your right angle, your hypotenuse is always opposite. The hypotenuse is always the longest side. Okay, it has to be the longest side, and you want to make sure that you don't just look at a picture and assume that they're in order. You have to make sure you find the longest side to test as your hypotenuse, or to put in that C part of your equation. So Pythagorean theorem is a squared plus b squared equals c squared, and your legs are interchangeable. You can call whichever one you want A and B. So let's try some of these. Let's try these examples out. So the first one's saying to find the length of the hypotenuse. So we have our sides A and B. We're looking for C. So I'm going to write down first a squared plus b squared equals c squared. And I'll substitute in the 18 for A and the 24 for B. And you might want to grab a calculator to do this, but 18 squared is 324, and 24 squared is 576, and equals c squared. So you always want to make sure you keep that equal to c squared visible. So we get 900 equals c squared. Now we'll take the positive square root only. And the reason why I'm only taking the positive square root is because we're talking about length or distance here, and you can't have a negative distance. So square root of 900 is 30. So I get 30 equals side C. I do want to show another little trick to do this. If I come over here, we have 18 squared plus 24 squared equals c squared again. If you notice your 18 and 24, they're both multiples of 6. So what we can do is we can divide these by 6 and just circle that. So you want to remember we divided by 6. And now we have smaller, more manageable numbers. And this is good if you don't have a calculator to use. You can use smaller numbers to figure out your answer. Okay, square root of both sides. So I get 5 equals C. Now remember, we divided by 6, so I need to multiply that by 6. And I get my 30 again. The second example on the front page here says find the missing side. That is a capital B, not an 8 there. As one of the legs, the other leg is 9, and then 16 is my hypotenuse. So I'm going to go ahead and put 9 here, and B, and 16. So I get 81, or actually 81 plus B squared equals 16 squared is 256. So now I'll subtract 81 from both sides. And b squared equals 175. Square root. So b equals the square root of 175. 175 is not a perfect square, but earlier in chapter 11, we learned how to simplify that. I know 25 goes into 175. How many times does it go in? It goes in 7 times. So I'm going to simplify that, and I get b equals 5 root 7. You could also use a calculator to approximate how long that is without your radical. Problem 3 is asking us to find the area of the figure below. So to find the area of a triangle, we need to remember the formula, half the base times the height. Base times height, they have to form a right angle, so we only know one measure here. We need to figure out what the other leg is. So when I look at this problem, I have a 35 as my C value, my hypotenuse, and then I will call 28 my A value. So I need to find B. Again, I'm noticing 35 and 28. Those are pretty large numbers. I really don't want to have to square those. So what I can notice is they all can be divided by 7. So I'm going to get my numbers into something a little bit more manageable. To work with, I have 5 and then 4 here. All right. So A is now 4, looking for B, and C is 5. We'll subtract 16 from both sides. We get B squared equals 9. So the square root of 9 is 3. So I found B is 3, but B is not really 3. We divided by 7, so I now need to multiply. I'll use pink for that. Multiply by 7. So B is 21. Right, now to find the area, area equals half, the base times the height. 21 times 28. Oops, let's see if I can get that there. So I'll do half of 28 first. And then I will just grab the calculator to do 14 times 21. And I get 294 square units. Actually, it gives us feet, so it'll be square feet. You might notice that this problem had sides that were reduced to 3, 4, and 5. The other examples earlier had that as well. These are called our triples. Triples are numbers that satisfy the Pythagorean theorem, and these are ones that you're going to want to remember. 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. Why are triples great? Well, triples are great because if you recognize them, you can really use them to save yourself some time. 16, 34. Oh, we can divide those both by 2. We have 8, blank, 17. The missing side is 15. I divided those sides by 2, so I'm going to multiply this side by 2, and the other side is 30. So you can use triples to save yourself some time there. All right, the last thing is what's called the converse of the Pythagorean theorem. It's saying if you have 3 sides of a triangle, if you square the sum of the smaller two and it equals the square of the larger side, then it is going to be a right triangle. So let's see example number 4 here. 7, 12, 15. 15 is going to be my C value because it's the largest. So we're going to test that out. 7 squared plus 12 squared, is it equal to, with the question mark with the equal sign, 15 squared. Okay, so we get 49 plus 144. I get 193. Then I get 225. Are they equal? No. So not a right triangle. And these are the steps you need to show to prove your work. Okay, letter B. Actually, number 5. 27, 36, and 45. So I know that 45 is going to be my C because it's the largest. But I'm looking at 27, 36, and 45, and I'm thinking, I don't want to use a calculator. I just want to simplify these. I can divide them all by 9. So I get 3, I get 4, and I get 5. Is 3, 4, 5 a triple? It is, so that's nice, because 3 squared plus 4 squared equals 5 squared. So 5 would be a yes. And the last one here, number 6, I have root 10, I have root 26, and then I have 2 root 6. I need to figure out what 2 root 6 is. So to get that back as a radical, I'm going to square 2, which is 4. 4 times 6 is 24. So which side would be the longest? Root 26. So this is my C. So let's check it out. Root 10 squared plus root 24 squared, is it equal to root 26 squared? What's nice about this is that your root and your square undo each other. So I get 34 equal to 26. Nope, so not a right triangle.